All right, students, this is lecture 3.5C. I've memorized the process of completing the square, and I can use this process to solve quadratic equations and rewrite quadratic expressions in a different form. So this is our third and final form that is used for quadratic functions. F of x is equal to a constant a times x minus h squared. So the quantity x minus h squared plus k is where a is something other than 0, is often called the vertex form. Okay, this is the third form. We've had standard form, we've had factored form, and now we have vertex form. The graph of this parabola in this form will open up if a is greater than 0 and down if a is less than 0. That's true for all three forms, by the way. The x-intercepts can be found when we set y equals to 0 and we solve for x. So that is when we cross the x-axis. We can find the y-intercepts by setting the x's equal to 0 in the equation and solve for y, and that will be the y-intercept. Now, the vertex, this is easy to find in this particular form. The vertex is the point h minus k. So let's take a look at this particular graph right here. Here's the vertex. It has a coordinate of 1 comma minus 4. X is equal to 1, and the y coordinate of the vertex is -4. I can go back up here and look at this formula, and I see that h is a value of 1 and k is a value of -4. And if you remember your dilations and reflections and transformations that we learned at the beginning of this unit, if I had x minus 1, I would move to the right 1. And sure enough, that's where the vertex went. It went over to the right 1. If I had a -4 outside of the function, then I would have shifted the vertex downward by 4. And sure enough, it did. So we can find the vertex very easily in when the quadratic formula is in the vertex form. Okay, they're easy to graph. So we plot the vertex. And one or two points on both sides of the vertex using symmetry. For example, maybe you find the y-intercept, and you maybe you just select a value for x, and then you'll draw the graph of the parabola through these points. Okay, we're going to review this at some point, but it's essential you understand all three forms. We've had standard or expanded form, factored form, and now we have had the vertex form. Okay, and in each situation, you need to be able to identify whether it opens up or down, how to determine its vertex, and also the intercepts in any of the three forms. Okay. All right, let's do some problems. We have the equation, or we have some equations here, and the instructions are to write each quadratic function in the vertex form, and we do this by completing the square, which is why we learned how to complete the square. And then we are to identify the vertex. Okay, so we have f of x. So basically, we're completing the square. We have b is equal to 16. 16 divided by 2 is 8. 8 squared is 64. So we're going to add 64 and subtract 64, and that will create a perfect square. And so we will factor that is equal to what? Again, how do we factor that? It's going to be something in parentheses squared. So what is b divided by 2? It is 8. So it's positive 8 squared. And then I have to combine these two terms here, and that will give me negative 14. And so that is now in the vertex form. And so we can quickly identify the vertex. Now be very careful. This is where I feel like we would get tripped up. Notice up here, notice here that we have x minus h, and h is the x coordinate. So if it's a positive, which it is currently, then the vertex is, the x value is -8, and the y value is -14. So be careful of that negative, okay? All right, why don't you try one yourself? Okay, welcome back. Okay, so what do we need to do? We need to put it in vertex form, and how do we do this? We complete the square. So we see that b is equal to -10. We got to divide it by 2, so we get -5. -5 squared is 25. So I have to add 25 and subtract 25. Why do we do this? We do this because this forms a perfect square. And so I will get f of x is equal to x. Okay, so this is where people stress out. What's b divided by 2? It was -5. It will always be that. And we will square it. And then we have to combine -26 and -25, and that will be -51. And this is my perfect square. And this is the other half of that equation. And so now we have a very easy way to identify the vertex. The vertex in this situation is the coordinates. Since it's -5, h is 5, and k is -51. Okay, that is the coordinates of the vertex. Has an x value of 5, -51. All right. Now, C, notice that we have a -1 in front of the x. We cannot have a -1. We want to have only 1 in front of x. So we have to factor out a -1. So we will get x squared minus 18x, leave a space, minus 70. Okay, now we're going to complete the square within the parentheses. So -18 divided by 2, -9, -9 squared. So I am going to add 81 and subtract 81 within the parentheses. Why do I do this? Because now this part of the expression is a perfect square. So let's rewrite this. -1 times, now I've got to have my factored form of my perfect square. So what was b divided by 2? -9. So I have -9 squared. I still have -81, and I still have 70. Now I have to FOIL. After that, -1 has to completely multiply through each term. And so I have a minus x minus 9 squared plus 81 minus 70. And then I have one more step. Okay, so this is the function in vertex form. That's part of the question. And then I have to identify the vertex. So the vertex is equal to, well, it's 9 because I have -9 and 11. Now, one thing I should also point out, we have a negative outside here. So that will be a, let's see, it's outside. So it's a vertical dilation, which means I will reflect it on the x-axis, which is why the parabola opens down. Okay, I have a plus 11, which means I will shift the vertex upwards 11. Okay, all right, moving on. Want to try one yourself? Welcome back. Well, the first thing we need to do is pull off that -1. So we're going to factor that out. X squared plus 6x, give yourself some space, plus 10. So 6 divided by 2 is 3. 3 squared is 9. Got to add 9, subtract 9. X, oops, plus 3 squared, still have the minus 9 plus 10, have to multiply through. Whoops, let's make that a little bit more visible. There we go. We did this because we created a perfect square here. Here that is. Okay, stop. Here's the remainder part of that. Now I multiply through by -1 through the whole entire expression. I get minus x plus 3 squared plus 9 plus 10. I'm just going to go ahead and combine that. Plus 19. And that is my function in vertex form. I was able to create that by completing the square. And then I can quickly find my vertex, the coordinates of my vertex. And what is it? Well, it's positive 3. And in the vertex form, we have minus h. So the x coordinate of the vertex is -3. So think of it this way. So if I have x minus a -3, oh, that's x minus a -3, there is my h value, okay? Because I have to have a negative in front of that h, okay? Hope that helps. And we have 19 as my y coordinate of the vertex. So let's think about a couple things. So I have a minus sign outside of the function, which means I have a vertical dilation, which means that I have reflected it on the x-axis. That's why it opens downward. I have a plus 3, which means I have moved to the left by 3. That's hence why the vertex has a -3x. I have a plus 19 outside, which means I'm going to take the vertex upwards by 19, which is why the y coordinate is plus 19. Okay. I'm not sure why that. Okay, there we go. All right. Couple more. I have no idea what that's doing. Oh, there we go. Okay. F of x is equal to minus 3x squared plus 24x minus 15 or minus 50. So we have minus 3 that we have to factor out. So f of x is equal to, we have to divide out -3 out of the x terms. So I get x squared and then -24x divided by, oh, no. Yeah, divided by -3, never mind, is equal to a negative, what is my problem? 8. Yes, 8x minus 50. Okay. So I take my b value, which is -8, divide it by 2, which is -4, square it, positive 16. So I'm going to add 16 and subtract 16 within the parentheses. That creates a perfect square. I will then factor my perfect square, and I will get x. What was b divided by 2? It was -4. I need that squared. I still have my -16, and then I have -50. I have to take this -3. I have to multiply it through the entire expression. I will get -3 times x minus 4 squared plus, I don't want to do that in my head, plus 48. And then minus 50. I will combine that. I will get -2. This is my function written in vertex form. And then what are the coordinates of my vertex? Well, I see that I have my h value, which is right here, is equal to -4. So my vertex, okay, come on, pen, has a coordinate of 4, comma, -2. Okay. Why don't you try one yourself? Welcome back. I have to factor out a 6. So I get x squared plus 2x, give yourself plenty of space, plus 1. I see that b is equal to 2. 2 divided by 2 is 1. 1 squared is 1, so I have to add 1 and subtract 1. I find 6 times, now I can factor this, right? This becomes my perfect square. And so I have x plus 1 squared. I still have my minus 1, and I have plus 1 outside. This is the portion of that expression that was my perfect square. Now I have to multiply through the expression by 6. I have to go all the way through each term. So I get 6x plus 1 squared minus 6 plus 1. I will then simplify. Minus 5. This is my function written in vertex form, and the coordinates of my vertex are -1, -5. Okay. All right, here's a couple of practice SAT questions. There's actually 3 of them. They're all your turn, so why don't you try them and then come back and join me. All right, so let's look at the first one. Which of the following is equivalent form of the equation of the graph shown in the xy plane above, from which the coordinates of the vertex A can be identified as constants in the equation? So here is the equation. Here is vertex of the parabola. And they have asked us to get the equation in a form that allows the coordinates of the vertex to be found very easily. And that is in the vertex form, which you can create by completing the square. How do we complete the square? Well, b is equal to -2. I got to divide it by 2. So I have -1. I got to square -1 and add it and subtract it. So I'm going to add 1, subtract 1. And why do I do that? I do that because I have created a perfect square right here. Okay. So that will be x minus 1 squared, -15 and -1 create -16. So this is in vertex form, and we see that this is the answer. And it is also, if you knew that it was going to be, if you recognize the fact that we needed to get it in vertex form and you understood vertex form, you could see that no other option here was actually in vertex form. You could have potentially answered that question without having to complete the square. Okay, the equation above represents a parabola in the xy plane. Which of the following equivalent forms of the equation displays the x-intercepts of the parabola as constants or coefficients? That is considered the factored form. Okay, so what we need to do is factor the equation. So we will say y is equal to, we need to find two numbers that multiply to 8 and add to -6. And that will be -2 and -4. And so if you were to find the x-intercepts, you would just set that equal to 0, and you would have the ability to quickly find the x intercepts, which is 2, 4. And so here is the format that we, the answer again is D. Just had to double check. All right, next one. The scatter plot to the right shows the amount of electric energy generated in millions of megawatt hours by nuclear sources over a 10-year period. Of the following equation, which best models the data in the scatter plot? So we can see some data. Now, this is a scatter plot because real data never is perfect. So it has some shape that looks like this, okay, which is a parabola, basically. And if I have a parabola, I have a vertex. and it's somewhere near there. I don't know exactly what the number is, but there's one thing right away that I would notice: it opens down. Since it opens down, then I know A has to be less than 0. Right away, I can come, these are all in standard form, and here are my A values. And I can see that this is a positive A value, so that opens up, and C is a positive A value, so that opens up. Therefore, that doesn't, those are immediately eliminated. The next thing we should be able to identify is I can see that the y-intercept is approximately 750. Well, where does the y-intercept occur? That occurs when x equals 0. So if I were to solve for the y-intercept for this particular equation, I would set x equal to 0, and I would find the value to be approximately negative 745. And if I were to set x equal to 0 in equation D, I would find the y-intercept to be positive 745. And so hopefully you can see that B is not the answer. And once again, we have an answer of D, which is suspicious. I always have these theories about multiple choice. All right, that concludes my lesson for the day. Look forward to answering your questions in class.